Okay, so you've seen triangles like this when you're in grade 10, right? But the information that was given in a triangle like this was very different. You might have been looking for this distance here, and you'd have to, like, that's given, you might have been looking for this in grade 10, right? This might have been your unknown. And so you'd have to find the lengths of both, like this bottom, subtract what's the length of that triangle, those two bases, and subtract them to get the difference, right? That's how we worked with the right triangles. Notice this time, though, what's given is very different. Sorry, the diagram's not that great because the triangle looks like it's not the same line, but it is. So here we have air balloon, weather balloon, okay, from two different tracking stations aligned on the same side of the balloon. So their angles of elevation are 17 degrees and 72 degrees. So this is not drawn to scale for sure. Tracking stations are 39 kilometers apart. What is the altitude of the balloon? So we're looking for what particularly? The height, right? BD here. Now, we can't use SOHCAHTOA here because in order to use SOHCAHTOA with the right triangle, we need to know two pieces of information, an angle and a side. But if I look at the big right triangle, so the very big one is, let me just use the highlighter. Okay, this big one. I know 17 degrees, but do I know the hypotenuse or the adjacent side or the opposite side? Do we know the adjacent? This is just this portion here. It's not the full length, right? If we look at the other right triangle, do we know anything about it other than the 72? And the 90, yeah, that's it. So there's nothing, we can't use SOHCAHTOA here. Somehow we're going to have to either use sine law or cosine law with this triangle right here. Because that's the triangle that I know something about. I know the 39, right? Let me zoom in a bit. So let's find out some stuff about that triangle. What else do I know? The side beside 72? Oh, that angle? Perfect. So this angle right here. See this angle here? We know that angle. Well, we don't know it yet, but we can find it. Because what do we know about a straight line? It's 180 degrees. And so these two angles add to 180, supplementary, just like our parallelogram. Okay, different, same term. Okay, so what is that angle right there? 180 minus 72 is 108. So 108 degrees. So now I know that's 108. What else could I find out? The top angle. Because what do we know about angles in a triangle? They add to 180. So 180 minus the 108, which is 72, minus 17. What does that give us? 55? 55 degrees. Okay, so that's great. Now that we know all these angles and we know one side, we can probably figure some stuff out. Which law could I use? Can I use cosine law? Cosine law we use if we have side angle side. Notice we have two sides. Or this formula is for all sides. Do we know all sides of this triangle? No, so we're going to have to use sine law. So we need to ask ourselves, do we know an angle and its opposite side? Yes, we do. We totally do. Use the magic pen, right? So we know 55 degrees and they're 39 kilometers, right? That is an opposite. So we know an angle and its opposite. We know all the other angles. The question is, what do we want to find out? Do we want to find CB or AB? It's up to you. You can find either one because we can use either bit, like either right triangle. So what do you feel like doing? AB or CB? CB it is. Okay, we're going to find CB. So we will use sine law. So we're using a side and its opposite angle, side and its opposite angle, those two. It's kind of messy. Can I erase that? So we're looking for a side. Are we going to use this first formula on the board or the second? First, if we're looking for a side, we want the side on top. So x over its opposite of sine of what? What's opposite of x? 108. We want the angle opposite of, right, in that green triangle. Equals, so is the angle going to go in the numerator or the side? The side, right? Side over angle, side over angle. So 39 over sine of what's the opposite of the 39? What angle's opposite of the 39 kilometers? 55. Okay. Multiply both sides by sine 108. So we can type that in now. Oops, let's move that over. Okay, so 39 divided by sine 55. Close the bracket for your angle times sine 108. Okay. You could also type it in as 39 times, I guess you don't need the time symbol, sine 108, and then divided by sine 55. It's the same thing. Okay, 45. Now, is that our final answer? Is that really what we're looking for? No. So we're gonna want to use that exact value later on, right? 45.28 approximately. So now we know that. How are we going to find the height? Of this balloon? You could use sine law. You don't have to. We're going to be working with this giant triangle. So you can't use Pythagorean because we don't know two sides. We only know a portion of that bottom side. We don't know the full amount. But we do know, like, here's the 17 degrees. If we draw this out, right? Here's the 90, here's our height, and here's the hypotenuse. So could we use SOHCAHTOA here? Yeah, so you can use SOHCAHTOA or you can use sine law. Sine law is the same thing as SOHCAHTOA. So what I mean by that is, do you know an angle on its opposite side? You sure do, the 90 and the 45, right? The 90 degrees and the 45.28, and then you're looking for the opposite here. So you can set this up with sine law. Sine law will work with a 90-degree angle because sine of 90 is just 1. So it works out to be an identical thing to SOHCAHTOA. Okay? Or, because it's a right triangle, we can just use sine of an angle equals opposite over hypotenuse. Sine 17 equals h over the 45.28. What do we have to do? Get h by itself by... Now, when you type this in your calculator, be very careful. Okay, because we want to use the exact value. So you either just want to push the time symbol and automatically it goes answer multiplied by. Or it goes second negative for answer times. We want to use that exact value, that full amount. Sine 17. Just gives us an accurate answer. So to the nearest, did I give you? No, I didn't. Let's go to 1 decimal place, nearest 10. 13.2 kilometers. Therefore, altitude is 13.2. Good old sentence. Gotta love that. Okay, I don't know if I made changes to this question. Let me double check. To determine the exact value of sine C, if angle A is 60, A is 15. Does yours say A? It says C. So change the A to 15. The reason why I changed that and C to 12 is I didn't want it to be an ambiguous case. Otherwise, it would have been ambiguous. And then that's a whole another can of worms. So I wanted to switch that so it's not ambiguous. Because it's an angle side here. So let's draw this triangle. We have 60 degrees. This angle A. The side opposite of A, angle A, is 15. So I switched it so it wouldn't be, if that was 12 and the other was 15, then we'd have an ambiguous case and we have 2 solutions. So I wanted to switch it. So this would be C, I guess. Okay. So whenever you see exact value, what are you thinking? Radicals, yep. So radicals, and what gives us radicals? Special triangles. I don't know how to spell triangle all of a sudden. My brain. Okay. I spelled it right? Triangles, yeah. I swear. One day when you get pregnant, if you ever do, you lose part of your brain. Okay, special triangles. So, do we know an angle and its opposite? Yeah, because it wants the exact value of sine C, right? So, that's this angle here. Let's set up the sine law, because we know an angle and its opposite. Sine C divided by what? Its opposite of 12 equals sine of 60 divided by its opposite of 15. Now we're going to have to do what to both sides? Multiplied by 12. We're looking for sine C. So we're trying to isolate sine C. That's what we're looking for. So those cancel. Those 12s. So we get 12 times sine 60. Put it all, right? Because this is 12 over 1. So with multiplying fractions, we go straight across, all over 15. Now we want this as an exact value. Do you remember your 60-degree triangle? 30, 60, 90. Okay, where does the 1 go? There's 2 places by the 90. The smaller side by the 90, yep. And it's opposite always of the 30. Because that's the smallest angle, so opposite of the smallest angle is the smallest side. So the 1's going to go down there. Hypotenuse is always 2. So 1, 2, root 3. 1, 2, 3. 1, 2, root 3, actually. Okay. So what is sine 60 then equal to? What is sine of 60? Root 3 over 2, opposite over hypotenuse, right? Here's opposite of the 60, and here's the hypotenuse. So root 3 over 2. Yay! Let's plug that in. So we have 12 times root 3 over 2, all divided by 15. Okay, what can we simplify here? Okay, I subbed in sine of 60. Sine of 60, right here, we use a special triangle. So early on, right? Sine 60 is right here. I replace that with what it's equal to. Root 3 over 2. Do you see that? So now I need to simplify this. I want to leave the radical, yeah. Okay, so the 12 and 15, we can reduce those. Yeah, we can. So we can divide both 12 and 15 by 3. So let's do that. So let's start there. So if we divide both by 3, we get 4 times root 3 over 2 all over. So we divided both the 12 and 15 by 3 is what we did. Okay, we reduced those coefficients. 15 divided by 3 is 5. Is there anything else we can simplify? How about the numerator? If I'm multiplying 4 by root 3 over 2, what is 4 as a fraction? 4 over 1. So if we went straight over across, would that be the same thing as 4 root 3 over 2? And what can we reduce there? The 4 and the 2. Yeah, which reduces to 2 and 1, or just 2 root 3. So the numerator, move this all back down here, just becomes 2 root 3. The 4 and the 2 reduces. One's on the numerator, one's on the denominator. So that gives us 2 root 3 all over 5 as your final answer. Yay! So one more question. I'm going to get you to try it on your own. Do you want me to help you with a diagram, or do you want to just try it with yourself? Help? A ship sails into harbor at a high tide. Let's zoom out. And the captain must sail under a bridge to get to the other side. The captain uses a special instrument to measure the angle from his ship to the top of the bridge. His first measurement is 2.3 degrees, and his next measurement is 3.3 degrees when he is 300 meters closer. The ship is 35 meters tall. Will the ship fit under the bridge? Now, we're not going to draw this to scale because those angles are pretty tiny. So we're going to exaggerate this a bit. So we have a bridge, right? And he's on the water. So the first time, he measures the angle of elevation to be 2.3. This probably looks familiar in a second. Then, from that point, he moves how much closer? 300 meters closer. And then he measures the new angle of elevation to the top to be 3.3. And he's measuring to the top of this bridge, right? So this is the bridge height, the height of the bridge. What are you trying to figure out here? Do you want, what's the question asking? Okay, will the ship fit under the bridge? How would I know if the ship's going to fit? It has to be smaller than the height of the bridge. So 35 meters has to be, our height of the bridge needs to be larger than 35. So we need to find the height of the bridge. That's what you're looking for. This question is very similar to the first one we did. So give it a shot, okay? It's really up to you. So if you solve for this length here, this x, okay, yellow, then you would have done x over its opposite of sine 176.7 equals 300 over its opposite of sine 1 degree. And you would have got 989.5. And then from there, I would have to use the big triangle for SOHCAHTOA. So that would be the 2.3 triangle. And so you would have 989.5 times sine 2.3 equals your height. You get 39.7. If you found out y, or my green line, then your sine ratio would be different. Y over its opposite of sine 2.3 equals 300 over sine 1. You get 689.5. And then you're using the small right triangle, but you still get the same thing. So your final answer, will it fit if this is the height of the bridge? Yes. The boat? Ship. Is there a difference? I don't know. Will it fit? Okay, so you have two options there when you're solving that. The bottom is just a review of special triangles. This is the end of the lesson. So you have a handout that I just gave to you. That's your assignment. It's two-sided. The answers for both sides are on the front, because that's where it fits. If you want extra practice, there is some extra practice on the math website as well. So when you're on the math website here, the extra practice button, click that. You probably would want 2.4. So here's extra practice. What does that look like? That's just the extra practice. That's just the solutions for all of those. So here's another one. If you want another one for studying tonight, the answers are then the extra practice answers. Okay? Yeah. So just to reiterate, your quiz will just be, I'll double check, but it should be just on sine law, cosine law. The special triangles can sneak in if I ask for exact values, right, using the sine law, cosine law, like we did in the last couple lessons. It's really the only way that sneaks in. Okay? Double check.